going to take a look at the 5.2 lesson. The 5.2 lesson starts talking about equivalent ratios. Equivalent means equal. Anytime we see EQU, the word in math is usually going to have something to do with being equal. So equivalent ratios are equal ratios. We're going to show these in ratio tables. The notes talk about adding or subtracting quantities. We are not going to do that. We are only going to multiply or divide by the same number to fill in these blanks in the ratio tables. So if I look at example 1, it says find the missing values. So that's how I'm going to earn 1 point, is by finding the missing values. And then I need to write, so that's where I'll earn my second point, the equivalent ratios. So here we have pens and pencils. There's 1 pen for every 3 pencils. And I need to start filling in this box right here that's blank. If I want to fill that box in, I'm going to look across from it at the 2 and figure out what could I multiply the 1 by to get a 2. I would do times 2. I'll do the same thing across the bottom. So from the first to the second box, I did times 2. So from the first to the second box, times 2. 3 times 2 is 6. Same thing again. Here's my empty box. Across from that is a 9. I can't go from 6 to 9, but I can go from 3 to 9. That's times 3. Since my arrow went from the first box to the third box, I'll make sure up here I go from the first box to the third box. 1 times 3 is 3. That's how I earn the first point for find. Now I need to write the equivalent ratios. So my ratios are the two numbers that are stacked on top of each other in the table. I'm going to go ahead and write them as fractions since they already kind of look like fractions. 1/3, 2/6, and 3/9. I don't need to do anything with those fractions. I don't need to simplify them. If they're improper, I don't need to turn them into mixed. I can just leave them written out as fractions. I could also have written them out any of the other ways that we talked about in 5.1 with colons, or I could have put words in the middle where those colons are. In example 2, we're starting with a word problem. It says you are making sugar water for your hummingbird feeder. A website indicates to use 4 parts of water. For every is my keyword letting me know that this is a ratio. 1 part of sugar. You use 20 cups of water. How much sugar do you need? In class, we kind of paused here and we talked about parts. When they say parts, they're leaving it open for us to choose what unit of measurement we would like to use. So, for example, if we're just filling up 1 small hummingbird feeder, we may choose to use tablespoons. 4 tablespoons of water to 1 tablespoon of sugar. But if I had a ton of hummingbird feeders that I was trying to fill up at the same time, or if I wanted to make some extra, I might use gallons. 4 gallons of water to 1 gallon of sugar. So for a part, we can use any unit of measurement we'd like to. I'm going to take the 2 things that are being compared in my ratio, water and sugar, and create a ratio table from those. So I'm going to put a long rectangle around it, draw a line between the 2 words, cut off that first column at the end of the 2 words, and then with this blank space that's left, I'm going to cut it in half and cut each section in half again. That way I have a couple different boxes that I can work with. The ratio the problem gives me is 4 parts of water. So next to water, I'll write 4, to 1 part of sugar. So next to sugar, I'll write 1. It wants to know what happens if I use 20 cups of water. So 20 goes with water down here. And I'm going to start to try to figure out what should be in this last box. How much sugar would I then need to use? I can go from 4 to 20 by doing times 5. I'll do the same thing down here. 1 times 5 is 5. So how much sugar do you need? You need 5 cups of sugar. If you are a student watching this video for extra credit, the secret code word is hummingbird. We're going to go ahead and take a look now at example 3. The nutrition facts label on a box of crackers shows that there are 240 milligrams of sodium in every 36 crackers. In every is a phrase that I look for when I'm looking for ratio, so I know my ratio is 240 milligrams of sodium in every 36 crackers. Then we eat 15 crackers and they want to know how much sodium we've consumed. The two things that are being compared are sodium and crackers. We're going to turn that into a ratio table, just like we did in example 2. The ratio that the problem gives me is 240 milligrams of sodium, so 240 goes with sodium, and 36 crackers, so 36 goes with crackers. A wants to know what happens when there are only 15 crackers. When we go to do this, and we try to draw our arrow from 36 to 15, there's nothing I can do to 36 to turn it into a 15. We would be able to use division if we could divide, but right now we can't. When a situation like this happens, we're going to go ahead and get the unit ratio. Later on in chapter 5, we will do the same thing, but instead of ratio, we'll call it a unit rate. Unit is 1. So I'm going to turn that 36 into a 1 and get a number up here, and then I'll turn that 1 into a 15. The benefit of having a 1 here is I can turn any number into 1 by dividing that number by itself, and I can turn 1 into any number by multiplying by the number I want. Now, we're going to go ahead and use a calculator. We're allowed to use calculators in chapter 5. So we're going to use a calculator to solve this problem. I did divide by 36, so here I will divide by 36. When I do 240 divided by 36 in my calculator, I get 6 point, a bunch of 6's, and then a 7. I'm going to clear that to double check it. 240 divided by 36. In this box, I'm just going to write 6.67. But I'm going to leave this number in my calculator. It is different because it has all those extra 6's in it, and it is going to make a difference in my final answer, and I'll show you that towards the end. Now that I have this number, I can look and see that the next thing I want to do is multiply by 15. If in the calculator I leave the answer to that and just hit the times, it will take my answer and multiply it by whatever I put in next. So the answer that was just showing on the calculator times 15 is 100. So we did times 15 and we got 100. So how much sodium do you consume? You consume 100, and then I'm going to look back up in the problem and see that they're measuring sodium in milligrams. Milligrams of sodium. In part B, it says you eat 21 crackers. How much sodium do you consume? This is why it's nice to have extra boxes. Instead of redrawing this whole table, I'm just going to take the 21 crackers and make sure I put 21 next to crackers. Because I've already found this unit ratio, I can go from 1 to 21 very easily. Times 21. With my calculator, I'll make sure I hit clear to clear out any information that it's storing. If I type in 6.67, I'm going to get a slightly different answer. So I'm going to repeat this step right here, 240 divided by 6.67, 240 divided by 36, so that I get the answer that I abbreviated and shortened and rounded in this box. And then we're going to multiply by 21. And I get the answer 140. How much sodium do you consume? You consume 140 milligrams of sodium. Now, I mentioned in part A that if I just use 6.67 instead of using the whole string of sixes, I would get a slightly different answer. So I just want to show that. If I just use 6.67 and do times 21, instead of 140, I would get 140.07, which would be incorrect. And again, if I just use 6.67 and do times 15, instead of getting 100, I would get 100.05. So it's okay to round it to put it into our table, but we want to use the whole number that shows up in our calculator. In example 4, we're going to take our ratio table one step further. You mix 3 pints of yellow paint for every 4.4 pints of blue paint to make green paint. So they're giving us a third thing. You use 10 pints of blue paint, how much green paint do you make? So we're actually comparing yellow, blue, and green. We're going to make this into a ratio table. They give me a ratio of 3 pints of yellow to 4 pints of blue. If we mix those together, we would get green. So that would mean that that would be a total of 7 pints of green paint once these were mixed together. It's then telling me we use 10 pints of blue and wants us to figure out how much green that would make. Before I can figure out how much green that would make, I'm going to need to figure out how much yellow I would need to mix with the 10 pints of blue. I cannot go from 4 to 10, so I'm going to go from 4 to 1 to get that unit that we talked about in example 3, and then I'll go from 1 to 10. So from 4 to 1, we're dividing by 4. I'll do the same thing here, divided by 4. If you needed to use a calculator to do that, you could. You're going to get 0.75. You could write it out as the fraction 3/4. Then to go from 1 to 10, we're going to do times 10. So from here to here, I will do times 10. 0.75 times 10, 7.5. Sometimes students get a little nervous getting decimal answers, but in 6th grade that's perfectly acceptable. 10 pints of blue mixed with 7.5 pints of yellow would give me a total of 17.5 pints of green. So how much green paint do you make? You make 17.5 pints of green paint. Thank you for watching the 5.2 lesson, and as always, if you have any questions, please feel free to contact me.